Mm-hmm.
Wow, it's cool. So and they're full-grown books. They're not little itty-bitty things. I mean, I figure 100,000 words is a nice introductory adverbial phrase.
Right.
Well, we're about to go live. Yep, it says we are streaming live.
So, hello, live and streamers.
Okay, how's
Clicky keyboard, Ivan. Yep.
okay, so far so good. Well, welcome to Sidewalk Science. Scott is not here today, and that means that I'm in charge of the technical stuff, and that's why we're 2 minutes late.
Better late than never. Mothers always say that.
Can you guys hear me okay?
Yes.
Good. Good. Before we start, I want to thank the American Humanist Association for their sponsorship of our stream today. This is a production of the Prairie State Humanists, and I'm Ivan Phillips. I'm the guest host for today, and we have with us some scientists who are going to tell us today all about ghosts and zombies and scary things, and less scary things like some science news. Maybe we should we can go around and give some introductions, some just brief introductions to people that haven't seen the stream before. Would you like to go first, Joanne?
Sure. I'm Joanne Reed. I'm out in the Chicagoland area. I'm a retired educator and chemist, and I also write fantasy books. Please go to my site on Amazon and buy my books because I'm retired and I need the income.
And Abby?
I am Abby Hafer, and I'm still working. I teach human anatomy and physiology. I have a doctorate in zoology from Oxford University, and I spend a lot of time writing about evolution and otherwise debunking bad science, or I should say pseudoscience, science stuff that pretends to be science but isn't really. So I tell people what science actually says.
John?
I'm John Doty. I'm another Massachusetts person along with Abby. And I'm a scientific instrument designer. I mostly design instruments that go into space, and sometimes I get to participate in the science that they do also. And I'm on Social Security, but I'm not retired in it.
Great. I'm Ivan Phillips. My training was in theoretical physics. My career is in software engineering. And I recently published a book, Textbook Rationality, which is about what rationality is and why we should teach it in schools. And I'm very interested in critical thinking and science outreach. We usually start the show off with some science news. And one story that caught my eye was a story, some work that's been done on the woolly mammoth, trying to figure out why they disappeared. And a paper was published recently in Nature about a 10-year study that was done, and it looked at it was like a genetic analysis of samples from mammoths and from tracking the plant life that was around at the time. So the question is, the mammoths disappeared at the same time as humans rose. So there's, correlation might be causation, and humans did consume mammoths and build stuff out of their bones and so on. So it's been hypothesized that humans are the reason that there are no more mammoths, that we killed them all. But this study points to a different cause. Rapid global warming caused the disappearance of the plants that they eat. And they would normally eat grasses, and the world became a lot wetter, and those grasses disappeared. And they studied this using the same technique that you use to test bulk that they've been using to search for COVID in sewage, right? Where you check for the presence of certain genetic traces in bulk material. And that's how they've been trying to identify which plants were around and which plants were consumed by the mammoths. So it's a very interesting study, and it makes you wonder, maybe something similar happened to a lot of the other megafauna that was around at the end of the last ice age. Does anyone have any?
Along that same line, a study just came out very, very recently about the Smilodon, the famous Sabertooth Tiger. And they were commenting about what went on with all these things. How did they die out, and the big wolves die out, while the smaller wolves, and especially the coyote, survived very nicely. And again, I think it comes down to the climate change kind of thing. Also, they've typically you see pictures of the Smilodons out there like lions on the open plains, and they looked at the dentition, and of course the food you eat is your teeth and your bones and everything else. So looking at this, they found that really the Smilodon is like most other cats. It was a cat that lived in the forest, it lives in the woods, and it hunted in that domain. Whereas the wolves and that kind of creature, which were the cursors, or the running kinds of animals, they were living out in the plains. So there was really very little interaction between them. But again, as climate change occurred, all the big wolves and that kind of thing disappeared. The American lion disappeared. The American leopard disappeared. The Smilodons disappeared. All the big cats went with the megafauna as well. So once again, climate change did it again, just like it's doing now.
Well, in a story of not going extinct, it turns out that California condors, which managed to not go extinct in the past 40 years, it turns out that they are yet another one in my collection of animals that do not need males in order to reproduce. So they're a sexually reproducing species, but they do not have to reproduce sexually. And this is something that is interesting to science because it has been assumed that multicellular species that reproduce sexually have kind of gone, up an evolutionary one-way path where we can't go back to self-replication, the kinds of self-replication that some simpler animals and protists have. But it's kind of amazing where once a phenomenon is discovered in one species, people maybe are a little bit more willing to either look for it or to accept evidence when they see it. That was certainly the case with various different same-sex sexual behaviors in nature, and bonding behaviors in nature, where once we started seeing it everywhere. But it was only really in about the 70s that same-sex relationships in other animal species were acknowledged by science, were actually, I should say, documented by science. And now we are documenting a growing list of multicellular species that can self-replicate. And so in this case, it's California condors, but other multicellular animals that can do this include a bunch of different kinds of sharks and rays, which are related, and lizards, as well as some others, can all reproduce, but do not have to reproduce sexually, so they can self-replicate.
So when this happens, are they identical clones, or is there some sort of shuffling?
No, I mean, there are some other things that are sexual reproduction, but that take place over much longer time than you would think. I'm trying to remember, there are certain species of animals where the females have what are known as crypts somewhere in their reproductive tracts, where basically if they're inseminated once, they can kind of put the sperm into a little hidey hole, the crypt, and just keep it there, and they may keep using it for a long time thereafter. But that's still sexual reproduction. When you have actual asexual reproduction, then you're cloning, yes. And I will say, just to sort of round this out a little bit, there is one new within the past, I would say 10 years species, which is an actual case of evolution in action that we've seen right in front of us, of the brand new all-female species of crayfish where there are no males. And it's a new species that basically is a mutation of a fairly standard southeastern US crayfish that became a popular aquarium pet. And somewhere along the line, probably in Germany, there were a bunch of mutations that took place such that these aquarium pets acquired the ability to self-replicate. And it actually became a new species. It's like 50% bigger. It's all female, and you can easily see the problem with an all-female self-replicating species of aquarium pet. You rapidly wind up with too many of them in your aquarium. And so they have in fact been let loose all over the world, and it'll be an interesting real-life experiment to see how long this lasts, because generally speaking, self-replicating species have some problems and do not last evolutionarily because they can't adapt very easily. They still have mutations, but they can't mix mutations the way that sexually reproducing species can. But on the other hand, so it's the kind of thing where, you know, over the long run, those species eventually die out unless they become sort of not obligate self-replicators. But the question in people's minds now is, what counts as the long run here? Does that mean the next decade, the next 100 years, the next 100,000 years? We actually don't know. So this is an unwitting experiment that's taking place in real time in many locations around the world.
And do we think it's possible that they could begin mating with some similar species?
With what, sorry?
With a similar species that's not, you know, like, so the definition of species is very tricky, right? Like in some, I remember in high school being taught, oh, if they can't breed with other species, but that's not really true, right? So some of it is, they're just maybe geographically or behaviorally isolated where they won't mate with something else. But do we know that about this new species? That, like, could it start mating with some other species of crayfish, and then you get some hybrids, and then it carries on that way?
All I can say is these things are weird enough that I don't see why not, but that doesn't mean they're going to do it. Because, as I said, we know the species from which it mutated, but it is very clearly different from this near ancestor. As I said, it's about 50% larger. So it's really easy to tell them apart. But whether they might then sort of redevelop the ability to reproduce sexually, it's anybody's guess. It could happen. As you kind of indicated there, one of the things that is both sort of interesting and confounding about biology is that we keep trying to make all these classifications and categorizations. Species is about the closest one we have to one that exists in nature. But even then, as you said, there are lots and lots of exceptions because it will have more to do with geographic isolation. And sometimes, as you doubtless know, I'm sorry, I should actually, Ivan, where do you live?
I live in the Chicago suburbs.
Okay, all right. I was going to say there are some famous sort of race circles, as they are known, where you can have a species that clearly has gene flow, but where there is some large impediment in the middle. So that what you will get, a classic one is actually the British Isles, where there is a species of gull that as it goes up one coast, it slowly changes in appearance. And when it comes down the other coast, it continues to change appearance. But so where they can actually both be seen at once, they are considered two different species by the local birders, but in fact, it's one in terms of gene flow. So as I said, things get a little bit squashy around the edges, and frankly, that's okay. And one thing that I will say, and I argue this about classification all the time, is that on the one hand, it is silly to argue too much about classification, but on the other hand, we couldn't live without it. We couldn't actually do science without it. Because if you don't start trying to figure out how to categorize things, then you don't notice relationships, you can't count things. If you're not willing to, distinguish between several species of penguins living on a given island, just to use an example, how can you tell which species is becoming more populous or less populous if you can't tell one from the other? So classification is actually incredibly important to science. I mean, consider your mammoth study. If we didn't bother classifying plants, we wouldn't know anything. But on the other hand, there are going to be places where some rule that we think we've made that is hard and fast turns out to be not as hard and fast as we hoped it would be.
So Michael in the YouTube chat says, talking about extinctions, and says, of course, the big question of the day for Halloween is what role did zombies play in animal extinction?
Well, I have a lot to say about animal zombies, but I'll let other people talk first.
Does anybody have any more science news before we start talking about the paranormal?
It's been a busy couple of weeks in the sky. One of the wildest things is the discovery of what is by far the farthest known, most distant known exoplanet, 30 million light years away. Discovered by one of my missions, one that I never expected to discover planets. Now I'm working with TESS, which discovers lots of planets. But this was discovered by the Chandra X-ray Observatory. And it's in a very famous galaxy called the Whirlpool Galaxy. You've certainly seen pictures of it. And what these observers saw was they were looking at what's called an ultraluminous X-ray source in the galaxy. And they saw a sudden dip in the intensity of this source, all the way down to background, as if it was completely blocked, and then it rose back up again. And with just one occultation like that, you can't make a solid identification of how big things are and all that, but you can look at the likelihoods and you can, kind of wave your hands, and or you can be a Bayesian if you were Ivan, but whatever. The most likely thing is that it was a Saturn-sized planet in an orbit that lasts a few decades. And it occulted the whole object because the whole object is presumably a black hole with an accretion disk around it. But the accretion disk scale is only 100 kilometers or so. So it's much smaller than a planet. So when the planet goes in front of it, it cuts it off completely. And, TESS typically finds things that are, 30 light years away. This is 30 million. And we're never going to see it again because you had to sit and stare at the galaxy for decades to see it again. And that with $1 billion instrument. And so we'll never see it again. The next thing is that the Jupiter's getting a little closer. The Jupiter's Great Red Spot is very deep. The results, the latest results from the Juno mission, where we've talked about spectroscopy in previous episodes here, and they use microwaves spectroscopically because the opacity of the atmosphere is different in different microwave bands, so they can see deeper or shallower depending on which microwave band they look at. And they see a signature of the Great Red Spot down to depth about 240 kilometers below the cloud tops, which is a lot. If you take a hurricane, the atmospheric pressure at the cloud tops is maybe 1/3 what it is at the bottom. For this thing, it's 1,000. It's several thousand. So, there's this huge change in the atmospheric conditions from top to bottom. And they're not even sure how deep it goes. There's another kind of measurement where you look at the density. They can actually, with Juno, you can track the spacecraft, and as it goes near Jupiter, they can actually find tiny micro changes in the trajectory due to the gravity of features on the planet, and they can actually measure the gravity of the Great Red Spot. And that measurement suggests that it's no deeper than 500 kilometers, but that's still very deep. Yeah. So that was a surprise. Then the third one, getting into wild edge science, was that a while back there was an observation of a radio signal that seemed to be possibly from something intelligent from the nearest known star to our solar system, Proxima Centauri. It was a narrow band signal, no apparent intelligence superimposed on it, no modulation, just a frequency drift. But it was unusual. And so there was the thought that this is the kind of signal that the people searching for extraterrestrial intelligence are looking for. And so maybe there's something there. Unfortunately, but typically, the folks involved in this went back and they did a detailed survey of the data recorded from this dish, not just from this one observation, but over years of observations. And it turns out that these signals happen all the time, and sometimes they're pretty obviously human generated, but they're pretty common. It's just that the Parkes dish is extremely sensitive, and it can see these things from hundreds of kilometers away. And so it's pretty clear that this was some human caused thing. They don't know exactly where it came from, but it's common enough that it's not a remarkable signal. They're happening frequently.
Right. Yeah, it does. It always reminds me of the story reminds me of the movie Contact. I didn't read the book, but I watched the movie, and at the end they say the signal could have been faked by a satellite, and I'm like, I don't think so. If you had multiple observing stations, right, listening to a signal in deep space, it's very unlikely that something in orbit is sending them both the same signal, and that's where they're seeing it from, right?
Yeah, and this, in this case, the signal lasted for 5 hours, and it just wasn't. It would have to track Proxima Centauri for 5 hours if it was actually something in the beam. On the other hand, if it's something scattering in from way outside the beam, it doesn't have to, and if it doesn't vary, that probably just means that it's somewhere on the Earth. Yeah, one of the cute things that most people don't realize is that if you have one of these big dishes and it looks a very narrow beam, about half of the effective sensitivity it has is from places that are way outside that narrow beam. Now, it may have 1,000,000 times more sensitivity to something straight in that beam, but then there's 1,000,000 times more area outside. And typically it's about a 1-to-1 ratio between the sensitivity to stuff coming in from the outside of the beam and stuff in the beam.
Cool. So our main topic for today is the science of scary things. And there's probably quite a lot to say. The first thing I want to say is that this stuff is popular not just with, people that are into ghost hunting and that kind of thing, but with people like us, right? So we love science fiction and fantasy, and I'm a big fan of the Ghostbusters. But there's a difference between being a fan of this stuff as fiction and believing that it's true, and that's where science has something to say about it. Joanne, did you have you were going to say a little bit about the history?
Yeah, the history of Halloween, of course, is most interesting. The celebration, which occurs at this time of year, has been around for 10,000 years at least. We look back at people who lived 10,000 years ago and we say, well, they were ignorant savages. And of course they weren't. They were very intelligent, very capable. And one of the things that they did was they looked in the sky and they saw that this is a circle. Every year, the same thing occurs at the same time. And you look at the sky, you see the constellations. And so they built. Stonehenge is just a recent example of some of the astronomical observatories that were built. Some of them that we're now finding go back twice as far into history. And so the people looked at this and they saw that the world went around this. There's a season, there's a seasonality, there was something you could count on. Then they saw everything as being a circle. Now, as we all know, a circle has no beginning and no end, except it has to have a beginning and it has to have an end. And by the myth of the European people, this beginning and end occurred at the time period which we call October 31st to November 1st. The year ends on October 31st. The year begins on November 1st. And there's a transitional period. As it gets dark, the connection between that which is and that which is not becomes very thin. Suddenly, at about midnight, you can go from the world of the living to the world of the dead. And again, back to the myth, it's always down. Everything is down and up. So you can go down into the dwellings of the people who have already died. But of course, they can also come up. And so there's a two-way transition going on in there. And the ghoulies and ghosties and long-leggedy beasties can come up and they can do things. They are physically capable of doing things. So what's the answer to this? Well, this is obviously a fearful time. This is a time of great fear. So the first thing you do on the 31st is you clean your hearth. You clean your entire hearth, you clean your entire house, you get everything out. And as the sun goes down, you lock your doors because the bad guys cannot go across the threshold. Now, I don't know why. All we know is that unless you invite them, they can't come in. So you close your door and you lock it. And nobody comes in and nobody comes out because they can disguise themselves. They're very good at it. And they can sneak into your house and do things to you. I don't know if they had probes. Maybe they had probes. But anyway, at midnight, the entire world is in flux. There's nothing constant. There's nothing that you can grab onto. Everything is in flux. And as the day goes on, and when the sun finally comes up, whatever it is. So whatever changes have occurred in that period from the sundown to sun up now exists for 1 year. And this, there's various words we use for this. It's spelled Samhain. Now, depending upon where you are in the world, there's a couple of different spellings because we, the Celtic people, have no idea what we're doing. At one time, there was a commonality of language that spread across all of Europe. And of course, it was during that period also that the North Sea didn't exist. And so you could go from the Ural Mountains to Ireland and just walk. So there was a continuity of language which gradually changed over the millennia. If you look at the differentiation between Scotland and Ireland, in Ireland, it's pronounced Soween. In Scotland, it's pronounced Shoane or Siobhan. And this MH sound is one of those peculiarities of the Gaelic languages. It can either be a B or a V or even a W. And it's different in Welsh, which is a completely different weird Celtic language, which we try to ignore unless you're Welsh. And of course, the Bretons have their own version of it, and the Cornwall has their version. But we're a split up group, and so it's been most interesting. And there were really two major holidays in this. There's the Siobhan, Samhain word, and then 6 months later, on May 1, is Beltane, and that's the spring festival. That's when the god Bel, who is the chief of the gods, returns from the south to the north, and we have a nice, wonderful. So these are the two opposites. In between, there are a couple of others that we variously celebrate. There is a summer festival, Lunastal, whatever you want to call it, and Lunasa, whichever you want to call it. And in the winter, we have all sorts of wonderful ones. Hogmanay, which is the January 1st. The Yule, which begins on the solstice and then goes for some period of time. And we're not sure what that time period is. It can get involved with the Yule. The Yule, of course, is the Yule log, the log of the yew tree. And the yew tree is a very slow burning tree. And so the winter festival lasts as long as it takes to burn the tree. So the objective is to cut down the biggest tree you can and let it burn. And the longest one is about 12 to 14 days, which corresponds again into the 12 days of Christmas and also into the Saturnalia of Rome and that kind of thing. And there's also Imbolc, which is February 1st. So within that time period of mid-December to the beginning of February, there are 3 or 4 different festivals, all of which we celebrate because, well, it's drinking time. In the north, the sun has gone down. We can't see it. It's cold. So let's drink. And also that's the time to repopulate the planet. You'll find that so many people from the north are born in the period of September, October, November. And that's part of the reason. But again, this was a very, very huge celebration. And the Christian church couldn't take it. They really got upset about it. And so in the 6th century, they took it over as All Saints' Day. And that's November 1st, which means that the evening before is All Hallows Eve, which is Halloween. And so I chuckle at some of the things I've seen on the Facebook and that kind of thing, that they want it to be Jesus Ween. So they really have no idea that it's All Hallows Evening and All Saints Day. So it's been around. The church has tried to usurp it in the same way the churches have always usurped Beltane, whether you're going to call it Easter or any of the other holidays. The same way that they've taken out the midwinter festivals and created a Christmas. So it's always interesting to watch these transitions from the old ceremonies based upon lunar and terrestrial and celestial observations, and how they have to be reformed to conform to the religion of the day. That's me.
I was just going to add, if I can, that Imbolc also corresponds pretty well to Mardi Gras.
Yeah, that's.
And the other nice thing about the sort of late December, early January holidays is that not only is it dark then, and there may not be much to do in northern climates, but you've also had enough time to brew beer and make wine. I mean, those things take a while to make, but as I said, once the harvest is in, and you're done doing all that hard work of getting the food in, then you can start, cracking grain and crushing whatever fruit you're not going to be eating and so on, or that you have too much of. And that's when you can start doing your beer and wine making. So, good time to have a celebration is once things are properly fermented.
For preservation. If we look back in Egypt, for instance, we can find that the beer that they made was a very, very hearty beer, that it was a food source, sort of like liquid bread at that point, and the same thing's going on. So the modern stuff that we have has been refined a little more than we would like it to be. If you go back a millennia or so, it was a relatively nutritious form of preservation, and you could go pretty well. So it was better than letting it rot. And then if you make it rot just right, you can drink it.
Well, it was better than letting the food rot, but it was also a way of sanitizing the water, because most places where there are large numbers of people, you usually wind up with foul water. And so you basically tend to have either boiled water cultures or alcoholic water cultures. And the Northern Europeans largely went for alcohol. But it's a way.
Stopped at Provincetown because they ran out of water and they had to make beer before they could continue on.
Oh, I didn't know that.
They stopped at P-Town before they got into Plymouth.
Oh, I know all about that.
So they needed to make beer.
There's an Ipsos YouGov poll in 2019 found that 46% of people believe in ghosts, and 32% of people believe that aliens have visited the Earth. 7% believe in vampires, and 6% believe in zombies. But I think that we could probably draw a cutoff at about 10%, because I think in any poll, basically 10% of people will believe just about anything, right? I don't know how much belief there is in vampires or zombies, but there are real life zombies, right? Abby, I know of that there are parasites that will tell mice not to be afraid of cats, for example.
Right. Well, there's a whole bunch of fun stuff like that. The one you are thinking of is Toxoplasmosis, which is a parasite that actually can infect many different animals. But when it infects mice, it makes them less afraid of everything, including cats. They really just lose their fear of cats when they are infected with this parasite. And wouldn't you know it, the cats then eat those infected mice. And that particular parasite has a special relationship with the cat digestive tract, because that is where they can breed. So then the parasites basically breed up in the cat's GI tract. And then when the cats poop, they are released back into the general landscape where mice may pick them up again. And so the cats actually make out very well from this. They don't seem to suffer from the parasite. They breed up the parasite, and it makes the mice easier to catch. But this is a case where the mice brain really is altered, or at least in terms of its behavior. The mice behavior actually is altered by by being infected by this parasite.
Of course, this is not the zombie in the zombie horror movie sense. I think horror movie zombies are usually creatures that are essentially dead, or shall we call them undead, right? Where they're at least rotting. Is there anything similar to that you know of in biology, or is when we say zombie in Toxoplasmosis case, we really mean uninhibited, something like that, right?
Brains have been taken over is the thing. Their brains in terms of their behavior, their brains have been changed. They've been taken over by this parasite. But if you want something that walks around while rotting, well, it's not so much walking as swimming, but ocean-going salmon at the end of their lives, as they have swum upstream, they basically sacrifice everything to the swim upstream. Many of their other systems shut down, their digestive systems kind of go away, and so on. And it is literally the case that these fish are rotting. They are dying as they swim upstream, or more to the point, they die and then they rot. They manage to, lay their eggs and fertilize them, and then that really is that. But they are swimming while rotten, basically. And there are many, many photographs and videos of these sort of, half rotten and half dead fish, or nearly all dead, except for that last little bit, swimming upstream in order to reproduce.
Isn't there also a species of wasp or something that kills, puts their eggs inside of other animals, other insects, and that other insect then becomes essentially brainless, but becomes a food source for the wasp? I remember something about that.
There are a bunch of different stories that are like that, but you're probably thinking of Ignomin wasps. And these are where the wasp will lay its eggs on a host, usually a caterpillar of one kind or another. And then when the eggs hatch, they paralyze the caterpillar, and the larvae then consume the caterpillar alive, and the caterpillar won't do anything about it. So, the caterpillar has been paralyzed by the either, I forget whether it's by the original egg layer or whether it's by the larvae, but one way or another, they are a live host who will eventually die from being eaten alive. And what's interesting about this also is that there's a little bit of science history in this, in that there are something like, I'm going to say, over 20,000 documented species of Ignomin wasps, and estimates are that there are actually many, many, many more. And, it's a pretty disgusting lifestyle, but they all do it. But this actually affected Charles Darwin rather deeply, because there was the idea in the Christianity that people in England, that the establishment in England believed at the time, which basically was that God was beneficent, and that if there was suffering in the world, that it was all kind of a part of God's greater plan. The problem of pain and suffering has always been a problem for any religion, and they take care of it in various different ways. But as I said, in Darwin's Church of England, God was beneficent, and any suffering was due to God's plan, which would create an overall better outcome. And so this was just a little bit of collateral damage along the way. And Darwin more or less said, I really can't see, why God would make these wasps do this thing. And I have also heard, though I have not been able to document it, that the fact that there were over 20,000 species of them definitely argues against a greater God's plan for why this might be necessary in a few extreme cases. So, as I said, that's the Ignomin wasps, which, as I said, have kind of a special place in science history.
Yeah. I don't know if anyone here has seen the movie Creation, which is about Darwin's choice
A long time ago, yeah.
to publish his work. Yeah, I really enjoyed that movie.
As far as ghosts
So-
are concerned,
So that leaves us with like ghosts and aliens. We've covered aliens in the past.
well, you do know
We should
that
probably
there was
talk
a
a little
fellow-
bit.
there was a fellow who commented afterwards that we had missed all the important stuff, and that he had all the facts and figures, and he would convince us all that the aliens had come and that they were responsible for human beings' existence, and that they are still here. And now I haven't been able to follow up on him, but now I know that you, Ivan, have been involved with many of these groups discussing them. What have you found about it?
So a lot of these paranormal theories are usually some form of conspiracy theory, right? Because the conspiracy is either on the part of the scientists to hide something, or it's a conspiracy of, in the case of the aliens, that, it's like a deep conspiracy that the aliens are hiding from us. So it's a conspiracy for the aliens to hide. And it's not impossible that the aliens could do that, but it seems on its face rather improbable, right? Because hiding is only one of the things that aliens could do. There's lots of things that aliens could do which are not hiding. And so it seems like that would be rather improbable. So that's sort of the Bayesian answer, is that even if you think that there might be aliens elsewhere in our galaxy, which I'm not too sure about, but even if you think they're there, it seems that if they came here, they probably wouldn't just hide, right? But in order to believe that they exist, you have to come up with a conspiracy theory. And I think that a lot of conspiracy theories are driven by a distrust of the establishment. And I think it is healthy to have some distrust of the establishment, right? We should, trust but verify, shall we say? But it sort of plays into a narrative, right? That we can't trust the government that's hiding the fact that UFOs exist, right? And I think that comes in other things like, vaccine hesitancy, shall we say, I think is often driven by something similar, where a person's ideas about who they should trust are sort of informing them as to what is true, right? Like whether we trust the government or not, the government makes plenty of mistakes, right? It's really a question of what does the science say, and how, why are scientists so different from average people that they're going to create these conspiracy theories? Because, I don't know about you, but if I knew that some major piece of science was faked, or that there was some important evidence about aliens, I would gladly go to the New York Times and collect my $500,000 or whatever they want to pay for the evidence.
Exactly.
As well as perhaps a Nobel Prize, who knows?
The whole idea of the entire scientific community being involved in anything where we are all in agreement and is hilarious. There's the Nobel Prize. There's all you can. The scholarships is money, and all you got to do is say you're wrong and prove it. And we don't. None of us. And it's and the idea of a conspiracy is hilarious. I
mean, on today's topic, one of my early experiences as a practicing scientist was being accused of witchcraft by another scientist, because I had used a novel data reduction technique to dig a result out of crappy data. And she didn't believe it. She didn't like the technique I'd used. Now, to her credit, she went back home. She had better data, and she went and confirmed everything I'd found and extended the results. So that's how science goes sometimes. But she did accuse me of witchcraft.
Well, and there's also just the whole business, getting back to Joanne's point, that scientists are actually pretty darn competitive. And although, there are instances of groupthink, and we might as well admit it, there are also lots of labs all over the world. And very often, even if there's groupthink in one lab, there will be another lab, maybe in another country, that's busy doing other research, finding out something completely different from what the first lab, thinks they've found. And so, by and large, as Joanne was saying, if scientists actually had good evidence for aliens, they would happily beat up on other scientists and outcompete them and say, here's my evidence. Deal with that.
money.
Give me the money, right.
They want to go down in the history books,
Right.
Written up in the history books for saying that these aliens exist and had the proof of it.
Right. The person who proved that aliens had visited, that would be worth quite a lot to a scientific career.
Yeah. The same goes for ghosts, of course. And in Ghostbusters, one of the things that I think is an important distinction, I mention it a little bit in my book, is the distinction between the supernatural and superstition, right? So in Harry Potter's world, for example, magic is part of reality. And by our standards today, we would consider it supernatural because it's not based on the sort of impersonal physics of atoms and molecules and fundamental particles. But it's not superstitious, because you could repeatedly test Harry Potter's magic, right? You could go into a lab and you can create repeatable experiments, and it is essentially a science of magic. It's perhaps a little bit more qualitative than we're used to, but it is something that you can measure with repeatable experiments. And so the same thing, in principle, there are aspects of human mentality that we could hypothesize might live on in a spirit world. There could be ghosts. There could be ghosts that could affect physical things. All of these things are at least possible in a sort of, they're conceptually, they're conceivable things. And they're conceivably could be measured in a scientific way, just like they do in Ghostbusters, right? They could trap ghosts. They can create measurement devices to measure them. Whereas ghost hunters today will take Geiger counters or measure electric fields and things like that. But it's not like they've done tests on small ghosts to make sure that this technology works. There's actually seems to be no connection, no evidence that the ghosts would even have this effect. And after years and years of searching for ghosts and hunting for ghosts, they're no closer to having developed some sort of technology to be able to find them or just to repeatedly see them. And so ghosts exist wherever there is human bias, science is all about trying to remove as much bias as possible. And so if you say science can't see a thing, you're saying the thing is only there when human bias is present. And so for most of the paranormal, that's the way it is. The paranormal studies don't actually make any progress. Whereas you look at astronomy, right? Astronomy has made a lot of progress over the century. Astronomy has made a lot of progress in like the last 10 years. Whereas, you know, a lot of the paranormal, you get more stories, you get more anecdotes. But it's superstition for the most part, in the sense that it's not done in a scientific way. It's not something where you get the repeatable experiment and you build up on knowledge that you had before into new understanding. It just never proceeds anyway.
I remember many years ago reading an article, and I've lost track of it completely, but in places where there's been battles and those kinds of things, and people have come out afterwards and cried, just enormous emotional outlets, that the ground itself has a chemical in it, which is the same chemical that we have in our tears, which will actually cause another person to cry. I mean, the tears of sorrow will create a feeling of sorrow in another human being. So, you know, it's good old basic chemistry strikes again. But they're suggesting that because this is a mass area where huge numbers of people were weeping and crying, and that it caused a chemistry in the soil so that other people who come there will feel that same thing. And if you've ever been on a battlefield, whether it's Culloden or Gettysburg or anything, you walk onto that field and there's something wrong. You go, what the heck is going on? There's a sensation there, and it's visceral. And you go, so could something like this occur? And if so, would this be the sensation of ghosts? You know, I'm good at questions.
I think it's a good question, but I guess my question is, and this may be in, you know, the evidence that you alluded to earlier, but my question is, so you said if you go to a battlefield that you can sense that something is wrong, and it's not implausible that there is some chemical trace that could cause that effect. But I would like to see the controlled experiment where you blindfold somebody and you take them to multiple places and get multiple people to decide whether they do sense anything wrong, right? Because maybe they don't. Maybe the fact that you go there
expecting
something is what, you know, alters the experiment.
Yeah. Again, what a wonderful research study for some, you know, 20-year-old PhD candidate. Ooh.
You know, that's very similar to what has been seen with experiments with extrasensory perception, where there have been numerous studies that show that participants can read the Zener card. Somebody can look at a Zener card and somebody else can tell what they're seeing, except that if you rigorously exclude every possibility of communication between the two subjects, they can't see the backsides of the cards, they can't hear each other exhale, things like that, then it doesn't work. Then the results are completely random. But people pick up on, either consciously or unconsciously, pick up on cues and manage to signal to each other. And so if you do this experiment with people face to face, sometimes they will show very strong capability of apparent extrasensory communication. But it seems that it's completely explainable by real senses, because if you block all the real senses, the effect disappears.
And there have actually been sort of good faith attempts at doing research on this for a long time. I mean, in addition to all the stuff done by the James Randi Foundation, much longer ago than that, at the turn of the last century in the late 1800s and the early 1900s, when there was a great deal of belief. People did lots of Ouija boards and seances and things like that at the time. And, there were the famous sort of, gatherings where everybody would hold hand and the table would wrap and all of this kind of thing. And it turned out that the people doing that really were knowledgeable charlatans, because they were very good at snapping their toes. And it turned out that that's what was making the tables wrap. But there were enough people who really, truly, genuinely believed this, that they did say, let's do the research, let's codify this, let's track things down and try and see if we can make some sense of this, because we know it's there. And they founded the American Society for Psychical Research, and it was nicely funded, and a whole lot of research was done, and they put out a journal and everything. But the problem was they couldn't find anything when they really, and these were people who really believed and really thought it was there and wanted to prove it to everybody else. And they couldn't do it. And actually, there's someone else who has something to say on this as well. I will be back in just a moment.
Yeah, and it's so common. I was thinking of Agatha Christie. You keep looking at the novels of Agatha Christie, and it's so often that they're involved with a seance. And that becomes the structure around which the murder mystery occurs. And, today you look at it, you go, a seance? Really? And of course, in her era, this was common.
They were very popular for a long time. And there's another woman whom I have met by the name of Susan Blackmore. I've got one of her small books here. That was what I tried to grab just now. And she told this very, very moving story of one time when she was in college, and she was, at a friend's place, and she just kind of relaxed for a while, and she swore up, down, and sideways that she had had an out-of-body experience where her body had, gone up above the rooftops and looked all around the town and had all these experiences and so on. And she, as an undergraduate, was completely convinced that she had done this. And she was going to prove it, basically. She had found her mission in life. She had had this happen to her, and she was going to prove that it had happened. And so she went heavily into research on out-of-body experiences, but being a good scientist, she was honest about her results. And the more she looked into it, the more it turned out that they didn't exist, or I should say that they only existed in the mind. I will not deny that they were experiences, but that their body or their consciousness actually went places and saw things is another matter, because she said, for instance, that with even the memories of her own experience, when she examined them as best she could, what she saw did not completely correspond to what the city actually looks like from above. I mean, now you can put up, send up airplanes, drones, helicopters, this kind of thing. We know what cities look like from above. And what she saw did not correspond to reality. And the more she looked into it, the more she became convinced that hers was not real, and that they were not real in general. And she has, had a lengthy career in doing this, I would say with a very good heart, but with results that are very convincing about how these experiences and, paranormal events in general, no matter how real they seem, don't actually take place, or at least not for supernatural reasons.
Wasn't there a surgeon or something that was working on a person's brain and almost by accident touched a probe into a certain part of the brain, and the person immediately, and again, this was one of those operations where you had to be awake, the person said they lost track and they were now floating above themselves and looking down, and they could turn this on and off. So there is evidently a locus of some kind of cells here, which confines your mental image of yourself as being within the body. And if you turn that off, it just sort of goes somewhere, and you can turn that on and off. Now, again, this is something I read and I don't have the literature. So please, someone look it up.
No, I will add to that there was some physician or other who actually had bookshelves I think it was him in his office, where he put a big sign on the top of the top shelf looking up. And the idea was that if anybody claimed to have had an out-of-body experience where they could look down at the building and see the people in it, he could then say, so what was that sign that I had pointing up on my top shelf? And he never got any takers on that. And unfortunately, eventually he had to stop doing it for reasons having to do with human subjects. Even though human subjects were not being actively dealt with in any way, this was nonetheless considered to not conform to human subjects' constraints.
I like it.
Yeah, I think Dan Dennett in his book Consciousness Explained, I think that's where I read it. There are similar experiments that can generate out-of-body experiences by, using cameras and, cameras and displays. And you can get people to have very strange experiences about being outside of their body. There's also, like things like the rubber hand experiment, where
Yes.
where what you do is you have a screen, and the real hand goes behind the screen, and there's a rubber hand in front of the screen that you can see. And what they do is they'll tickle the rubber hand that you can see and your real hand at the same time. And after a couple of minutes of this stimulation, then they can tickle the rubber hand with the feather, and you will feel it.
And they take out a hammer and strike the rubber hand, and you ching! And it just,
a bit of cruelty
Yeah.
or drama to the experiment. But yeah, so our perception of what we are, what constitutes our body and where we are, is, a mental projection, because, all the thoughts that we're having, all the things we see, the photons that we are looking at, they're not hitting our brain, they're hitting our eyes, going to our brain, which then creates this
magical world in which I live.
Yeah, I hearken back to my graduate student days of sleep deprivation and hallucinations caused by that, snakes and spiders, and being able to see sounds and things like that.
Mhm.
Our perceptions are not rigorous scientific instruments.
No.
Well, that's why.
It was the thing I did a couple of years ago. I was discussing the whole subject of cognition and that kind of thing. So the first thing I did was come up with a whole series of optical illusions, and many of them were in real life, where there's a person that's there, you're talking with a person, and people will walk through your vision with a table or whatever, and a completely different person is standing there. They just walks off, and they continue the conversation as though it was the original person. And you get so many of these things where this thing isn't really working well. We think it is, but it's not.
Well, there's some nice everyday things like that as well, where if you take a blow to your eyes, you see light. And that wasn't photons hitting your eyes, but that's the way that retinal cells respond to stimulation, is they see light. There we are.
We live in a world where really our world is something in here. It's not out there. And we do the best we can with what we got. we got a certain range of eyes that we can see, and we interpret it. We throw 90% of it away. We keep the taste, touch, and what do? And that's why I think we as scientists are somewhat weird. We do not expect ourselves to be infallible. In fact, we expect ourselves to be very fallible, and we have to operate as a group. And even then, we recognize the fallibility. So we build machines, and the machines get extended, but even then, it's fallible. So we keep reiterating to try and find our fallibilities and come up with something which we think is probably pretty good. And then, yeah, we're scientists. And the rest of the world looks at us and goes, huh?
I think to a lot of people, what we as scientists have the same everyday experiences as most people, right? That if our sensory inputs give us certain information, it's sort of model based. We have a model of the way the world works, and we're going to interpret what we see and hear as best we can in terms of the model that we understand, right? So I think that for many people, what's most real to them are their friends and their family and other people and their feelings and the relationships that they've had. And so if when people don't have an alternative physical model where they're not paying close attention to the limits of our sensory perceptive abilities, then if you get noise, if you get a signal like that's wires crossed or something unexpected, you're going to interpret that signal as best you can in your model. And like this must have been this person that I knew and loved is communicating with me in some way or something along those lines. So there is intuitively, there's a very similar process. It's just, I think that being scientists, we have a more physical model, first of all, of how things work. And eventually we're going to sort of backtrack and say, okay, well, let me think about that experience. Is there any way that I could have been mistaken about that?
Infinite.
When Galileo, who was quite an astute observer, first turned his crude telescope on Saturn, he thought he was seeing a triple planet. He thought he was seeing 3 balls in a row because his head was primed to see spheres in the sky. What he was really seeing was the rings on either side of the planet. But that was not something that was yet within his, prejudices or imagination. And so he really thought he was seeing 3 globes. But what we do is we make more observations and we look closer and, oh, that's not 3 globes. That's something more interesting,
Then you turn it over to someone else and say, hey, look at this. Look what I see. Do you see the same thing I see?
Yeah.
And
a lot of that. I told you about being accused of witchcraft and the accuser going off and looking at her data and verifying what I'd seen. So it was, but she did, what I had seen was not within her sphere until she had verified it with her own data.
Right.
Yeah, that's one of those things about.
Like if somebody has some procedure that they're going through with numbers that shows up a pattern, right? There's a lot of abuse.
Oh yeah.
With that, right? Numerology is about finding patterns in what are essentially random numbers, and you can always do it. You can always find these patterns. Sometimes, there's pareidolia as well, where we will see patterns in marble flooring, right? We'll see, oh, look, here's here's a horse, or here's a person smiling back at me. But it's really just random noise. But
We
random
name
noise,
those patterns, those patterns are constellations, and we give them names. And we identify stars according to which constellation they're in.
We have bears with tails.
Yep, bears with tails. Yep.
But
we
there
were
are,
talking about Section Centauri. How about those horses with people attached to them?
well, but another thing that happens where pareidolia are concerned are that there are certain things that we are primed to notice and interpret in certain ways. So, two dots close together are going to be interpreted as eyes, which is why we see faces in lots of different things. I mean, we may see dogs or cats or rabbits or whatever, but we see lots of faces, which makes sense when you think about it, because, if there are two eyes that are looking at you, it might be a predator, and you are better off over interpreting signals like that and doing false positives rather than not noticing that pair of eyes that turns out to be a predator. So we actually are primed to see faces. And there's some fairly good evolutionary and survival reasons for it. Likewise, as a fun fact to know and tell, it turns out that in experiments of basically trying to instill fear, it turned out that with monkeys, even with a completely unrelated kind of fear stimulus, the usual electric shock, but could monkeys learn to associate various patterns with this bad stimulus? And the answer is, like dots in different configurations and this kind of thing. 3 dots in a row would tend to lead to a fear reaction being trained into a monkey much more quickly than other patterns. Where do monkeys live? Where there are snakes that are bad for you. So again, there are all kinds of predilections to see things that may or may not be there simply because they have some benefit they had some benefit to our ancestors' survival. So we've got them, like the primate spider reaction, which is basically primates hate spiders. Humans can learn to be okay with spiders, including me, but most people do not have to be trained to be afraid of spiders. That comes quite naturally to us, and some people are truly terrified of spiders. And that we have it in common with our primate relatives.
Snakes too. Snakes, you get a baby can be afraid of a snake.
Right. So as I said, a lot of pareidolia, at least sort of the more obvious common ones, as I said, like faces, spiders, snakes, this kind of thing, we are primed to see those things.
Yeah, I'm not particularly afraid of snakes or spiders, but when I'm sleep deprived, I see them everywhere.
I'm okay with snakes, but spiders. I remember the King Kong movie that was made years back that on the island there are all these giant bugs. I could barely watch it. I was surprised. Normally I can watch, giant bugs on screen, but this was too much for me. So
I'm not bad with snakes, but spiders get to me.
No second entomology career for me.
So Ivan, there you are. You're a primate.
Well, what about John?
Well, I've got the layer in the brain that is primed to see them, but then it doesn't connect to the panic layer.
Well, and we can learn to not be afraid of spiders. And, you know, I had a number of pleasant experiences as a child letting Daddy Longlegs walk on my hand with no adverse effects. So I wound up being okay with spiders, but I think that it's more that I learned to not be afraid of them.
A little bit
Now-
earlier about the basic idea of cognition and how we interpret things. One of the things that we've discussed, we found out, is that essentially the first 3 years of a human's life are critical. That's when you form personality. And once that personality is formed by the age of 3, that's you. And everything else becomes layers like an onion. But that first 3 years is the core of your personality. So if you've been brought up during those first 3 years to say, this is true, then it will always be true to you, and it'll be almost impossible for you to get out of that. That's one of the things that we have about born again and that kind of thing. So again, that first 3 years, the more we look at that first period of a human life, the more interesting it becomes, because from the time you were born, you are learning instantly. You are really picking things up, and this thing is growing enormously. You're seeing an entire new world, and the explanations you receive at that time stick.
Well, then I was remarkably fortunate because I spent my first 3 years at Cape Canaveral. And it's actually a rather rich natural environment as well, with lots of lizards running up walls and other fun things. I mean, this was back when it was barely developed. The space program was in its infancy at the time. So there was a lot of wild natural life in Florida, just sort of there. And on top of that, there were a lot of smart people to talk to, even a small child. And there was Spanish language TV and all kinds of fun things. So for a child of that size, it was actually quite a good environment.
So
People who are born in a closed environment have a great deal of difficulty breaking out of it. As in the more open you've been as a child. I know my parents explained everything, and there were books, and we had encyclopedias. And if you were asked a question, you got an answer. By golly.
Regarding like the effect on very young people, I'm a little skeptical about that. I need to see the citation, I think, to be persuaded. But I can certainly imagine that there are extreme environments where that can have long lasting and very powerful effects on people late in their life. I was gonna give a personal anecdote, but I decided not to.
Well, before we close out, I did want to you were talking about things we believe in and things that we don't. And one thing that you can actually believe in is vampires, because they actually exist. So I did just want to put in a good word for vampire bats. And, Dracula may have been a human who could turn into a bat, and that bit is fiction, but vampire bats really do exist, and they really do suck blood and use it for their nourishment.
People who raise cows down in that area are just upset because their cows have these big bleeding gashes in them, and they go, ugh, because the bat actually, when it bites, its sputum and everything else will stop coagulation of the blood, so it continues to flow. Yum, yum.
That's what leeches do too, actually. Leeches have some kind of an anticoagulant in their saliva. So those things really do exist. We may not like them, but they're there.
So it seems like the vampires and the zombies are the ones that do exist, and the ghosts don't. So.
Oh yeah, plenty of zombies. I have lots of examples of those, and a few good vampires.
A lot of people to whom sunlight is very, very bad. I can't remember the exact Perforia. Is that it?
I didn't hear you. Sorry.
There's a lot of people to whom sunlight is very, very bad, and so they avoid sun and they come out at night, and that helps that whole genre of things to continue to prosper. Is that before you? Is that the word?
I'm not sure.
Yeah, I don't know. Well, we're actually at about an hour and a half through the show. So if unless we have anything else to add, we should probably just say Happy Halloween to everyone.
Remember, clean your all the ashes out, clean your house, lock the doors, nobody in or out, and so the ghoulies and ghosties and long-legged beasties will not disturb you.
Except for trick-or-treaters, of course. Trick-or-treaters, you need to give them
When they're
something.
small, then you feed them candy, and that's
You
okay.
feed them candy and they go away.
Okay, thank you, everyone.
Have a good one, guys.
Okay, have a great
Bye-bye.
weekend.
See
Happy
you.
holidays.
Happy Halloween.